Good morning children. Today let us see the sum of exterior angles of a polygon. What do you mean by polygon? A polygon is a closed figure made up of line segments. Example, triangle, quadrilateral, pentagon, etc. The polygon may be a regular polygon or a irregular polygon. Regular polygon is one in which all the sides and all the angles are equal. For example, equilateral triangle. In an equilateral triangle, all sides are equal and all angles are equal to 60 degrees. So, you call this equilateral triangle as a regular polygon. Similarly, if you are going to consider a quadrilateral square, you call this square as a regular polygon because in square all sides are equal and all angles are equal to 90 degree. Now, moving on to this triangle ABC, here you are having three sides AC, BC and BA. As you learnt earlier, the sum of angle sum property of a triangle is 180 degree. That is angle A plus angle B plus angle C is equal to 180 degree. How do you get an external angle? That is, if the side AC is produced, this one angle is produced over made over here, which you call it as an exterior angle. Similarly, when AB is produced, you are getting an exterior angle over here, and BC is produced, you are getting an exterior angle. All angles that are lying outside, you call it as exterior angle, and the angles inside, you call it as an interior angle. This I will show it in this triangle. Interior and exterior angles. In this figure, A, B and C are lying inside. So, you call this as interior angle, and these angles are lying outside. You call these angles as exterior angles. Now, let us visualize how we got the sum of exterior angles as 360 degree. So, as you know earlier, when the sides are produced, you are getting an exterior angle. So, in this figure, angle 1, angle 2 and angle 3 are exterior angles. Let us visualize now. Suppose a person wants to walk through the boundary of a triangle. Assume that he is starting at this dotted point. He will be moving along the line AC. After reaching this point C, he will be turning an angle 2. Then again he will move along the line BC. After reaching the point B, he will be turning an angle of 3. After reaching the point, turning an angle, he will move along the line BA. Again, after reaching the point A, in order to come back to his original position, he has to turn an angle of 1. So, totally how many times he has turned? He has turned 3 times. That is, he is covering one full circle over here. What is the full angle in a circle? It is 360 degree. Therefore, we can conclude the sum of exterior angles he has turned over here is equal to 360 degree. This can be extended to other polygons also. So, in quadrilateral, if you are going to make an exterior angle, he will be making a 4 turns over there. In a pentagon, he will be making 5 turns. In general, he will be covering one full circle over there. So, the sum of exterior angle is equal to 360 degree is common for all polygons, whereas if you are going to consider the interior angles, it differs for different polygon, and already this formula we are derived in the previous class. That is, the formula for finding the interior angle of any polygon is n minus 2 into 180 degree. Hope you have understood this method, visual method. Next, let me prove this sum of exterior angles is 360 algebraically. Here the sides of the triangle is produced. What you are able to observe that angle 2 plus angle 3 is a linear pair. So, it is equal to 180 degree. Similarly, 1 plus 4 is 180 and 5 plus 6 is 180. So, let us take it as 3 different equations, and adding the equations we are able to observe that sum of all these angles is equal to 540 degree, but we know here angle 3 plus 4 plus 5 is an interior angle. So the interior angle of a triangle is 180 degree. So 180 plus 1 plus 2 plus 6 is equal to 540 degree, or 1 plus 2 plus 6 is equal to 360 degree. By subtracting 180 from 540 we get 360 degree. So we have proved that the sum of exterior angles of this triangle is equal to 360 degree. So this we can generalize for other polygons as, suppose if you are having a triangle, how many linear pairs you had? You had 3 linear pairs. Similarly for quadrilateral you will be having 4 linear pairs. For pentagon you will have 5 linear pairs. By adding all these angles you will conclude that the sum of exterior angle will come out to be 360 degree. This is how we have proved algebraically. Now using this method, can you find the sum of exterior angles of the below polygon? Now we can generalize the concept over here. As I said earlier, in a triangle there are 3 sides, therefore there are 3 linear pairs. In a quadrilateral there are 4 sides, therefore there are 4 linear pairs. In a pentagon there are 5 sides, there are 5 linear pairs. So a polygon of n sides will have n linear pairs. So we can conclude that the sum of exterior angle of any polygon is 360 degree. Now coming on to the next topic, what is a diagonal? A diagonal is a line segment that connects the non-consecutive vertices of a polygon. So here you are able to see the quadrilateral ABCD. Here when you are joining this you call it as a diagonal. I am going to join this diagonal. I am not taking the next vertices. If I am going to join the next vertices, it becomes a side of the quadrilateral. So I am going to leave this vertices and join the next vertices. When you are going to join the next vertices, it becomes a diagonal. Similarly, if you are going to take the next B over here, we are not going to join it over here as it becomes a side. We are going to take the next vertex over here. So this becomes a diagonal. This is followed in all the polygons. So we are see how we are joined the pentagon. So in a pentagon also you are getting how many diagonals over there? 5 diagonals are there. So this can be derived by the formula n into n minus 3 upon 2. This generalized formula you can use for finding the diagonals of any polygon. So now it is a quiz time. Can you find the number of diagonals in an octagon and septagon? So what is the formula you will be using? You know the number of sides in an octagon is 8 and number of sides in a septagon is 7. So you can use the formula over here as n into n minus 3 upon 2, where n stands for the number of sides of a polygon. Next, find the angle sum of a decagon. Decagon means 10 sides. Angle sum means we had to use the formula n minus 2 into 180 degree. Find the sum of exterior angle of a hexagon. We know that the sum of exterior angle of any polygon is 360 degree. So for hexagon also it will be 360 degree. Find the each exterior angle of a nonagon. We know the total exterior angle is 360 degree. How can you find each exterior angle? Each exterior angle can be found by dividing the number of sides, that is 360 degree divided by 9, as nonagon is having 9 sides. What is the minimum interior angle? This I am leaving to you. You have to find this answer. What is the minimum interior angle and the maximum exterior angle of a polygon? Hope you have understood this PPT.